Hello, everyone. Thanks for joining us again in this series. So previously, we talked about concave and convex mirror terminology and sign convention. I suggest you review this if you haven't seen it. Then we analyzed the image of two objects, one inside and one outside the focal point of concave mirrors by ray tracing and thin lens equation. And now we're going to do a few exercises and a couple of videos just to illustrate the points that we talked about. So please like, subscribe, share, comment, suggest topics and problems for us to look at and maybe make videos and post those videos. All right, so let us begin. So we have a 2 centimeter tall object. Let's see here, placed 45 centimeters to the left of a concave lens with a focal length of 15 centimeters. Let's describe the image. Okay, so we're given the height of the object. So let's write down what we know. Okay, so H sub O is 2 centimeters. It's placed 45. So this is D sub O, it's 45 centimeters, and F is 15 centimeters, all positive. Let's talk about the image, basically its location and magnification. So let's go ahead now and 1 over DI plus 1 over DO is 1 over F. That's what we're given, find basically HI and D sub I. So I'll bring this over. Common denominator. Flip them to get DI isolated by itself. All right, well, let's see what we get here. F is 15. DO is 45 over 45 minus 15. So that's 15 on top times 45 over 30. So we can divide here, we get a 2, and 45 over 2 will give me 22.5. We can just leave it as 45 over 2 also. Sometimes the math works out better that way. So here's the image distance. It's real because it's positive. Okay? The eye is positive, obviously. It's a real image. And for real image, it's going to be inverted, and we'll see that in a little bit. With the magnification. So let's look at the magnification. M is negative DI over DO, which here, by the way, is HI over HO. So let's look at the DI over DO. So negative DI is 45 over 2. That's why sometimes it's easier to keep them in fraction, because now things will cancel out. And that will give me 45's cancel out, gives me -1/2. So I have a magnification of, again, 1/2. Basically, I reduce the size by a factor of 2, but the negative tells me it's inverted. So less than 0 means inverted. So let's look at H sub I. H sub I equals M times H sub O. M is -1/2. H sub O is 2, so -1 centimeter. And again, H sub I is less than 0. This implies the image is inverted. right? Let's see if we can. So we have now the height of the image, we have d sub I, we have the magnification. Let's see if ray tracing gives us the correct thing. So again, here's 45 centimeters, 15. So 1, 2, 3, 4, 5. So every unit is 3. So let's go ahead and draw again the first ray coming parallel to the optical axis, hits the mirror, reflects through the focal point. The second one is perpendicular to the lens, which means going through the center, it comes back up on itself. And then the third one going through the focal point, that red dot coming out parallel. So they all meet here. So the image is right here. It looks like it's 1 unit. It's inverted. And let's look at its distance. So if this is, again, each is 3 units. So it's 5, that's 15. And here we have 18. You have 21, 24. So between 21 and 24 is where the image is. And this is what we got. We got 22 and a half. So it's roughly in the ballpark right there. The rays actually look good. So that is where it's supposed to be. That's about 22 and a half over here. Okay, between 21 and 24, which is actually exactly 22 and a half. Okay, so it's inverted, real. The rays of light go through it. And it's 1 unit, roughly. Here it came out a little bit more. But again, depending on the rays, the accuracy. And it's on the right side of the object, 22 and a half centimeters. Right? So that's it for the first problem. Let's move on to another one. So I have a concave mirror with a radius 40 centimeters. Right away, whenever we're given the radius, it's positive 40 centimeters because it's a concave mirror. F is the radius over 2, which is 20 centimeters. Forms a virtual image 10 centimeters away from it. So we have a virtual image that's 10 centimeters away. So d sub I is negative 10 centimeters. So basically, here's the d sub I. Okay. What is the object's location? What is the magnification? Now we know the object has to be closer. We talked about that in the previous, on one of those videos. Check them out. Maybe it's the 3rd video. And we illustrated that in the lab quickly. So let's just see if we can actually get a confirmation here. So we need DO and we need M. So let's solve it. So 1 over DO plus 1 over DI equals 1 over F. Bring DI over. Get a common denominator. Sorry, that's DI right here. Apologies, DI minus F. Now we flip them. All right. And let's see what we get when we plug numbers in. F is 20 centimeters. DI is negative 10. Over DI is negative 10, negative 20. So I have 20 times negative 10 over negative 30. So the negatives cancel out. And I get roughly 20 over 3. I mean, I get 20 over 3. Not roughly, exactly 20 over 3. Okay, centimeters. So that's roughly, again, here's the, roughly 6.7667. So the object is positive. That's great. That's a check. It's closer to the lens than the image. That's, again, 6 centimeters away. The other one is 10. So that is good. And this is great. This looks like we're on the right track. Now let's look at the magnification. M is negative DI over DO. Negative. DI is negative 10. DO is 20 over 3. So this is like plus, again, the plus 30 over 20, which is 3/2, or 1.5. That's the magnification. 1.5 times as large as the object. So the object is 2. This will be 3. The image will be 3. And the fact that it's positive, it's upright. It's upright. And virtual, upright and virtual. So let's go ahead. Again, virtual, they even gave it to us. Let's see if that is supported by the ray tracing. So here's my object. I start with my object at around 6.667. Okay, a little bit. So let me see here. Okay. So this is like, each of them is 2 units. Or 1, 2, 3. That's 6. That's 9. So it's over here somewhere. I may have overshot it a little bit. Let's see where we get the image. So again, first ray parallel to the optical axis. Oops, that should have been up a little bit, but let's go through the focal length. The other ray is green through the center, bounces back on itself. And one ray is parallel, go through the focal length as if it's coming from the focal length, comes out parallel. And they don't meet over here, but if I trace them back, they meet over there. There it is. There's my image. So 1, 2, 3, 4. So it's at negative. See if each is 2.5. Actually, at 5, it is 2. So 1, 2, 3, 4. It's at negative 10 roughly. And here is at roughly negative 6.7 or 6.7. Okay. And there it is. It's virtual. There's DI, there's DO, there's F, there's R. Okay. And so again, that's a virtual image. And again, this is closer to the lens than the image. All right. So this is it for this video. In the next one, we'll do a few more exercises, maybe 3 exercises. And that will be it for this series before we move on to convex mirrors. All right. Thanks for taking the time to watch these videos. And again, we hope they're very helpful and informative to you. Thanks. Bye-bye.